DIY everyone. I'm Mike. Today we're going to take a look at this treadmill. It's been having some problems and the belt won't move. So we'll do a little bit of troubleshooting and figure out how to fix it. I think it's going to be a motor that needs to be replaced. So let's take a closer look. We're going to turn this on. And we see the display lights up. It's got some power, so that's good. The controllers, the brains behind it seem to work. If I push start, it pretends it's going to start, but doesn't start moving. As I turn the speed up, it doesn't move. However, as I push the incline, it raises. So the incline motor is working. So we're going to take a closer look at the motor for moving the belt. Perhaps it's also a fuse. Now before you start taking things apart here, make sure you turn the power off and disconnect your power source. I want to make sure we're safe, don't get electrocuted. We're going to begin by removing these screws. There's 2 on each side of this cover. Then we'll get the 2 on the other side. With the screws removed, we can pop the cover off. Let's see what we've got in here for the motor. Now you might have a fair bit of dust in here, so we're going to clean some of that out. Alright, so I've cleaned out the dust in here, and taking a closer look, right over here I think I've found the problem. I've followed the wires from the motor, and they connect to this control board. And somehow this is burned up here. So that's going to be the source of the problem. So this piece that's stuck here actually came off the control board itself. So that's definitely a problem. So let's see what we can do about that. Alright, so with this burned out, I reached in and was able to remove, I don't know if you'll be able to see this, I was able to remove the small pin that tied on the circuit board, and it looks like it melted and got damaged right there. So we need to figure out if the motor's failed or if it's more from the circuit board. So looking at the motor nameplate, I see the volts over here. It's 90 volts DC. And so because it's DC, I know I can use some DC electrical battery to test it. So let's take a look at one way to test this. I've got my 18 volt battery. This is a DC battery for my cordless drill. And we're going to take, this is a little bit hokey, but bottom line, I've had to get some wires. So I took an old extension cord. I recommend you don't mess around with the electricity unless you have some good experience and know what you're doing. I can't be responsible for any stupidity out there or any accidents. So use caution and care. Make sure you're comfortable with doing whatever you choose to do. But this is what I did. So I'm going to connect to my red and black wire here. I'm just going to put one side in there and get the other one in here. Make sure nothing's crossed. Alright, we're going to put one on the positive and one on the negative. And lo and behold, our motor gets going. The belt moves. So that suggests to me that the problem is not the motor, but really the circuit board over here. They got burned up. So let's see if we can figure out what we need to do there. Alright, so I've removed power once again. I do see, however, that there's still a red light glowing on this board down around the corner. And as I learned in a painful way before, sometimes these boards will have not sure the right name, a device on them that holds up a charge and can release that. So you want to be careful, but what I'm going to do is get some of these wires out of the way. So I'm going to snip some zip ties. Now, before I did this, I've taken a bunch of pictures so I can make sure to reassemble everything to the proper places once I'm done here. Alright, so let's finish getting these screws, these two screws, and that's going to let this whole board assembly, it appears, will let the whole board assembly come out. Yes, it's loose. Alright, well let's take a look at the supplies and parts that you're going to want for doing some soldering. So obviously we have a circuit board. Now in this case, because this is one that's mounted onto this metal angle, it's got some screws coming in here that hold on components down there and a bunch of pins here. I really didn't want to mess with trying to get this off and not being sure if I could re-secure everything that needs to go on it. So that's why we're trying to solder from the top. Now there's a couple points I need to do, one right here in the middle and one here on the edge. So in this video I'll try and do the one at the edge so we can see what's going on underneath as well. You may need some needle nose pliers, you'll need some solder. Now if you're from other parts of the world, sometimes it's often referred to as solder. I don't know why in America we're calling it solder when it's certainly spelled like solder. Some parts, components to repair. In this case, it took me a little effort to track these down. I found them from DigiKey, which is a great resource to find components like this, digikey.com. But it can be challenging. You really have to search to hunt and find the correct parts. We've got a damp sponge. I have a soldering iron. Fancier ones, you can control the wattage. This is a small, inexpensive one. I'll include a link on Amazon where you can pick up a kit to solder. It's a 40-watt unit, so usually somewhere in that 30 to 40 watts is a range that will work for small electronics. And then we've got a solder sucker. That's a tool that can be used to remove excess solder that gets on. I mentioned I found the replacement components on DigiKey. Now to do that I took the one that was damaged and used calipers to make measurements, and then had to search around and look at the drawings, figure out what this part was called, and search around with the drawings of each component until I found one that had the same measurements. And it seems to be a great fit because I've got two pins that this is going into right here, and it lines up well. So we'll try going through the top of the board here to do the soldering. I'm not sure if it'll work, but we'll give it a shot. So I've got my soldering iron. I've tinned it already. I'll do that once again. So in doing that, I'm just touching a little bit of solder on the end of the iron, and then using my wet sponge just kind of to help clean it off and get it ready. I'm going to try to heat up my component here. So apply some heat onto these two pins for a little bit, and then after that I'll try putting my soldering iron through these holes briefly. I don't want to melt the circuit board or other components, but I do have solder on the back side that's not allowing this to go down. So I need to melt that, and then we'll apply just a touch of solder from the top and hope that it works its way down through these holes and makes the wire connections that are needed. You want to make sure you're safe while you're working on this. Obviously the circuit board's not connected to any kind of electronics or power. Don't make the mistake of heating this component up and then grabbing it with your fingers. That's why I've got these needle nose pliers. So I'm trying to apply a little bit of downward pressure while heating up this component, trying not to melt the circuit board in the process. And I'm going to apply a little bit of solder on the back side as well. This is the one that we just put in. It looks like it's about the same height as this one. I can see the pins. Let's see if we can line that up. The pins can be seen sticking through the solder down here. So it would seem that we've made it through. Well, I'll go ahead and see if I can do the same thing, repairing the one down at this end, and then we'll test out the circuit board. Now that this had a chance to cool down, it's feeling much more firm than before. So looks like we've successfully attached it. Hopefully it's actually made the connections that it needs. Given a gentle tug, it's certainly not feeling loose. So there you have it. We've made the connections and hopefully repaired the circuit board from the top, which is a little bit of a unique scenario that you don't run into too often. We'll test it out and go from there. Alright, so now that we've repaired this circuit board, the moment of truth will come. We'll have to get it wired back up. Okay, so I think we've hooked all the wires back up, however, except for here. Now remember, this burned out, so I'm actually going to have to splice these wires on so that there's new connections to secure down, because I don't trust this one anymore. So the first thing we're going to do is cut the wire. Now I should say before we get going that you need to get yourself a wire cutter. This is a pretty old one, but still works well. I'll include a link where you can pick up a multi-purpose wire tool on Amazon. This has a lot of different features and we'll go through using several of them today. So the first thing we'll be doing is making a cut. Alright, so we're getting our wire in place. We're going to squeeze hard, snip the wire off. So that's the first step. We've gotten this old device off. So now how to strip the wire. So in order to strip the wire, first you need to find out what gauge the wire is. To find out the wire gauge, wire will have printed along it the gauge of wire, the thickness of the wire. In order to strip the insulation off the wire, to expose the wire, look down the side and find the gauge of wire. Here's a 16. Looking at my wire, I find it says 16 AWG, so it's a 16 gauge wire. And we can then line up with the hole for number 16. Just like that. Get the amount of wire that you want exposed. We'll squeeze it down. I'm going to rotate this to cut all the way around the wire, and then we'll pull it off. And in this case, there we go, just like that. Now that we've pulled the insulation off, you want to take and twist the wires together. Yep, we just twist them together. That'll hold the wires together so that they stay when we go to put our connector on. With our wires connected, we're now ready to put it into the connector. So I'm going to check my length here. I'm going to check the length. It looks like it's pretty good length. This is an insulated quick connect that will be connecting with the circuit board this connects to. We're going to slide the connector onto the end of the wire. And then we'll use our crimping tool. We're lining up, we're matching yellow to the yellow dot, and you check your wire gauge. and then squeeze down nice and tight. All right, now that we've got our wires crimped back, this will be a little bit hard to see because I think my hand's going to get in the way, but we're going to reconnect the black to the spot where the black one goes and the red wire to where the red goes, and then we'll test out the motor and see if it's working. All right, now that we've put the wires back on the circuit board, let's turn this thing on, see how it works. First trick, let's give it some power. That's a good sign, it's beeping. All right, next trick, can you push start? Uh-oh. That fried the circuit board. Yep, so the power connection, the same one that was burnt before, is burnt again. So we've got to replace the entire circuit board. Hopefully this was helpful for you in solving whatever problem you have. Thanks so much for watching Tomahawk DIY. Like the video, leave some comments, and if you feel up for it, make a donation. There will be a link up in the upper corner of the video here. And have a great day.